And let me explain the situation here. So we're talking about factoring in general. So it's this document right before this page. Right before this page is this document. Do we all have it? Yes? Okay, perfect. So factoring is divided into 3 different categories. This is the way I like to present it. I think that the previous books, the prerequisite for this class, are not really doing a good job. I think that this is a better structure. Factoring is split into 3 different categories. One, did I start? Yes. Binomial, trinomial, and the last one is polynomial. Okay? So we're going to discuss a strategy for all 3. They are different. When I'm asked to factor a binomial, I will use a certain strategy. When I'm asked to factor a trinomial, a different one. When I'm asked to factor a polynomial, a different one. So let's start with the binomial. So factoring a binomial. Here's the strategy. So now I would like you to, I'm going to write it anyway, but I would like you to go back to the next page. Just go to the next page. The top part is identical for all types. If it's a binomial, a trinomial, or polynomial, it doesn't make any difference. I have to present it in descending order, no matter what it is. I have to find the greatest common factor, no matter what it is. And I have to factor out a negative leading coefficient if there is one, no matter what type of polynomial it is. Then, from this moment on, it's different. If I have a binomial to factor, then I have to think of in terms of these 4 special products. If I'm given a trinomial, then I'm going to think in these 4 different situations. And if I have a polynomial, that's the easiest possible, just factoring by grouping. So first let's analyze this, and then that. Ready? So I'm going to choose a binomial, or you choose any binomial you want. I would like to start, let's say, with this one. And then you can choose the next. I have some examples in here. So 4x squared minus 25. Maybe before I do that, maybe I should write these steps one more time for you. Let's write the steps one more time. So in step number 1, I'm asking myself what type of polynomial is the one that I have to factor. So for this question, there are 3 possibilities, right? What are those 3 possibilities? 3 answers possible. Binomial, trinomial, exactly, awesome. And number 2, let's say I establish it's a binomial. I'm asking myself, is it in descending order of the powers
You mean that? You mean least square raised to least?
of the variable? Yes. If it's not in descending order, I have to rearrange it. Step number 3, greatest common factor. Greatest common factor. If there is one in all terms, I have to pull it out. Number 4, negative leading coefficient. If the leading coefficient is negative, I have to pull it out. These 2 can be performed at the same time, if you wish, if you want to. Final step is number 5. There are 4 different special products here. The a squared minus b squared, which we know. We have a week already. Can anyone tell us how to factor this one? Awesome. We already used it so many times in rational equations. Very good. Thank you, Tony. Indeed. This we have to dream about. This should never, ever be a problem moving forward. Good. The second one is a squared plus b squared. This is very important. However, it's not factorable. So this is a sum of squares. Sum of squares. Not factorable. To be exact, I should write not factorable using integers. It is factorable, but not using integers. Okay, then we have this, and we have this. How do you think these are called? We have never discussed them. They are slightly more difficult to work with. But what do you think their names is? The name of the first one is, and then the name of the second one. Sandra, say it one more time. Yes, difference of cubes and sum of cubes, of course. Difference of cubes and sum of cubes. So these two are slightly more difficult. Let's work on one, and then the other one will follow very easily. So let's suppose we are given this. And you could say, how did you come up with this? Where is this from? Where is it coming from? Bear with me. So what is this quantity called? It's a factor here. So what is this called? We used it so many times. It's a how do we call two terms? We know the terminology by now. Excellent. A binomial. Excellent. Binomial. What is this? Very good. So I'm multiplying a binomial by a trinomial. So please give me the steps. Distribute slowly and tell me what to write.
We're distributing it out.
There is nothing else I can do.
So a cubed minus a squared b plus a b squared.
Excellent so far.
And then ab squared. No, a squared.
AB squared
Yes.
plus
Yep.
plus B
No,
cubed,
b
sorry.
cubed.
Now let's take a look. Let's take a look. Look at those 2, 4, 6 terms and say, ah, without the ah. Say what?
So some of them could cancel. Like you have a minus a squared b and a plus a squared b, and then you have.
So what is the final simplified form then?
It's a sum of cubes. Or,
Of course. No. It's just the sum. So now I can go back and say, how does the sum of cubes factor? And it factors into a times.
no, she's saying that's how it's going to factor out.
So the sum of cubes factors into a times.
I try to.
Correct. So moving forward, we have to remember this. So a cubed plus b cubed. Please give us the trinomial and the binomial. First, the binomial, please. What term cubed is a cubed?
A.
Very good. Plus b. A squared. There must be a minus somewhere, and it will never be at the last term. So minus ab and plus b squared. So this is the way we factor the sum of cubes. Now, what will you say about the difference of cubes? Correct.
B squared plus
Exactly.
plus B squared.
This is it. Perfect. Awesome. So now we're ready to choose any binomial you want, and we will look at any formula, special product that is applicable here. So let's start with the first one. 4z squared minus 25. I'm going through all these questions. I'm going through all these questions first. What type of polynomial is it? Very good, it's a binomial. Is it in descending order?
Yes.
Is there a greatest common factor?
No.
Is there a negative leading coefficient?
No.
Wait, no.
No, because it's 4 and 25, that's okay. And now my question is, can I apply a special product? I have 4 different special products that I can think of. However, only 2 of them have minus. So I'm not going to consider the ones with plus, right? So, because I see a difference. So I went through all these steps. I got here. This is not applicable because it's a sum. This is not applicable because it's a sum. So I'm only considering these 2 because they have a difference.
Maybe a square could be
Exactly.
used by
It will be the difference of squares. So then, what do we have?
2z minus 1.
Very good. Awesome. Very good. Indeed. This needs a lot of practice. If you don't remember factoring from the previous classes, I should not be doing this at all, but I started from scratch, assuming that you have never seen it before. But this is a prerequisite from all the classes before. You do have an assignment on factoring in my math lab.
And that 2z can't put you on subtract, right?
Say it again.
You subtract the 4 from the 2. I mean the 2 from the 4, that's how you got the 2z.
No. It's this formula.
Oh, this is the second.
First term squared minus the second term squared. It's the one we talked about last Wednesday. Okay. Next problem. Let's say y cubed plus 8. Any questions? So please ask. Please, ladies, gentlemen, please ask. Okay, what type of polynomial is it? Binomial. Is it in descending order?
Yes.
Greatest common factor?
No.
Negative leading coefficient?
No.
Special product? I always hope for a special product. Special products are always easier than anything
It's
else.
the sum of squares.
Sum of cubes.
Sorry.
Once you say sum of cubes, then you will prepare a binomial and a trinomial. So can anyone give us the binomial? And let's discuss the sequence of signs first, because it's very important. If we're factoring the sum, the binomial will always have the sum and the trinomial will always have the minus in the middle. If we're factoring the negative, then the binomial has negative and the trinomial has positive. The last one we don't ever discuss because the last one is always positive. So the sequence of signs is like this: plus, plus, minus, or minus, minus, plus. Please remember that. Okay, so can anyone give us the binomial?
Y plus 2.
Do you all agree with y plus 2 as being the binomial? So here's how we build the trinomial. We square this and we put it here. We square this and we put it here. We multiply these 2 and we put it in the middle. Ready?
Where you get y to plus 2?
Y to the third is y to the third. 2 to the third is 8. Y to the third is y to the third. 2 to the third is 8.
Cube root of both of them and put them in the binomial.
That's another way of putting it. Which quantity I cubed to get y cubed? Y. Which quantity I cubed to get 8? 2. It's the same with here. Which quantity I squared to get 4z squared? 2z. Which quantity?
I don't. That y3 is throwing me off. Y to the third and you. How did you get y by itself?
I'm asking myself, what quantity will I ever cube to get y cubed? And the answer is y. What quantity could I ever cube to get 8? And the answer is 2. Because this is not a sum of squares. There is nothing that I can square to get an 8. There is nothing that I can square to get a y cubed. And furthermore, it's positive, which will not be factorable anyway. So it's either they are both perfect squares or both perfect cubes. Since they are not perfect squares, I try whether they are perfect cubes. And they are perfect cubes. Is that better?
I think once you do the rest, it'll make more sense.
So let's square this and put the answer here.
Y squared.
Let's multiply them and put the answer here. Let's square this and put the answer here. That's it. Now, if you don't remember these two special products, what I would do at the beginning when I practice, I would multiply them out. And when I multiply them, what should I get? Otherwise, this is bogus. Exactly. Excellent. This is what I would do till I get the hang of it. I will write the formula, I will write the binomial and the trinomial, and then I'll say, wait a minute, let me use multiplication distribute on the side to make sure that I get that.
You have to put the y, like you know how you did y and then y squared. You have to put, does it matter what order? Like if you would put y squared first plus 2, would it have mattered? Instead of y, because you chose.
You mean the binomial?
No, just the y squared. You know how there's a y squared and there's, yeah, and then the first one there's a y.
She's asking in place of in the binomial.
But this is the pattern. The pattern says I have to square this and put it here.
Okay.
I have to square this and put it here. And in the middle, I have the product.
Okay.
I can't change this pattern. So the first term squared minus the first times the second plus the second term squared.
Okay.
I'm only following that pattern. Is that better?
Mhm.
Yes, please.
The answer to that C. Where's the answer to that?
To-
Is the answer in here?
Just no, I don't have the answers there.
Oh, just, okay.
Yeah, we're working on any problems you want. Okay, so let's look at 1 over 27 minus x to the third. And then I would like to move on to trinomials. Okay, what type of polynomial is this?
What type of what?
What type? So I'm going back to my first question.
Like a binomial.
So first I have to identify what type of polynomial, then descending order. If not, I rearrange it. Then the greatest common factor, and then the negative leading coefficient. And then I have 4 special products to think of if we are facing a binomial. So what type of polynomial is it? Perfect. Is it in descending order?
No.
No. So I have to rearrange it. Does it have a greatest common factor?
No.
Does it have a negative leading coefficient?
Yes.
I have to pull it out. What is left in parentheses when I pull out -1?
X cubed
Yes.
minus
Yes.
1 over 27.
Very good. So now I'm finally at the stage of special products. Is there a special product that I could use here? There are 2 special products with binomials that have positive, or there are some, and 2 of those that have a negative or a difference. Which of these will you look at?
The difference of cubes.
Do you all agree with the difference of cubes? Because there is nothing I can square to get x cubed, and there is nothing I can square to get 1 over 27. So it must be a difference of cubes. Once you say the difference of cubes, what will you prepare then? A binomial times?
Trinomial.
Excellent. So if you follow me and my lead, and I know I sound like a broken record, it will get embedded in your brain. It will. Just follow through, be patient, and you will get there with me. Okay, so let's identify the binomial, but first the sequence of signs. When I factor the difference of cubes, what do I have inside the binomial?
A minus.
Correct. What do I have inside the trinomial in the middle?
A plus. and then a
Awesome.
plus.
So it's either minus plus or plus minus. Awesome. Good. Can anyone identify other than Mallory? Can anyone identify the binomial for us? X is good.
Aren't you trying to get 27 by
1 over 27. I can change 1 over 27 into 27. Excellent. Awesome. So x cubed is x cubed, and 1 over 3 cubed is 1 over 27. Perfect. Thank you. Good. So now the trinomial is easy. Once I have the binomial, the trinomial will follow. What is the first term in the trinomial? What is the middle term in the trinomial? Awesome. And what is the last term in the trinomial? Very good. 1 over 3 times 1 over 3. Excellent. Yes, because that's the pattern. Yes. So the first term squared plus or minus whatever I have, AB and plus B squared. Because I can have the sum or I can have the difference. Very good.
I don't know. I did the 1/3.
1/3 times 1/3. Oh, it's 1/3 cubed is 1 over 27. Yes. Any questions?
And there's the answer.
That's it? Oh, well, I'm sure you'll, yeah, we can. Trinomials. Okay, so I go through the same stages, same steps. Number 1, what it is. Number 2, descending order. Number 3, greatest common factor. Number 4, number 4, negative leading coefficient. These are the same. Same from before. In number 5, special products. And I should have written here special products for everyone to understand. They're called special products, or formulas, right? Special products. So there are 4. 1, 2, 3, 4, although one of them is not factorable for binomials. Here we'll only have 2. Here's 1. Please not to confuse this with this. This is the trinomial coming from the sum of cubes, or the trinomial coming from the difference of cubes. That has nothing to do with this. Notice they're not the same, correct? So do not confuse those two. And what do you think the other option would be?
Plus.
Okay, what do these equal to? Say it again.
Like if we factor it out.
Yes. Yes. Okay. Not only, you're on the right track. Correct. This is what we covered last Wednesday. That's what I said. I don't want it possible. Hopefully, we don't want to talk about this ever again. This is it. This is what we signed. We signed an agreement a week from today. A week ago today on this. Now, there is also 6 and 7 here, which are more difficult. 1, x squared plus bx plus c. And the other option is this. So back for a moment to that summary of factoring. Here's where we are. Of course, what type it is, descending order, greatest common factor, negative leading coefficient. And here are the 4 possibilities. This is one of the special products from last Wednesday. This is the other one. And this is a type with 1 as the leading coefficient. And this is when the leading coefficient is not 1. And of course, the last one will be the most difficult one. Okay, so let's work on a few problems and see. Yes, they're right here, just in case you miss anything. They're right here, these 2. So 1 x squared plus bx plus c, and the other one a x squared plus bx plus c. Okay, oh, back to my handout. So no, B, yes.
Yeah, sorry,
Yes.
I forgot that they're B's.
And they're, yes, they're right here. Right here at the bottom. 1 x squared plus bx plus c, and then the next one is right here on the next page. with ax squared plus bx plus c. Okay? So let's start on the trinomial. Okay, let's say x squared minus 4x plus 4. Okay. First question. What is the first question? What type of polynomial is it? And the answer is a trinomial. Is it in descending order?
Yes.
Greatest common factor in all three.
None.
Negative leading coefficient.
No.
No. Special product. There are only two special products. What do you expect this to be? Looking at the first term and the last term, and knowing that the middle one is negative, what do you expect this to be if a special product works here? I'm not saying it does, but if it does, what will you write? Very good, awesome. However, this is not sufficient. I must check the middle term. So how did I come up with x minus 2? By simply looking at x squared and looking at 4 and knowing that this is negative. But I have not checked the middle term yet. When you expand this, can anyone tell us what will be the middle term? Remember the pattern. The first term squared minus 2 times the first times the second plus the second term squared. Indeed. Since the middle term will be negative 4x, would you agree that the left-hand side equals the right-hand side? We do?
Wait.
Yes, it's correct. I'm going to change the problem now for you. X squared minus 7x plus 4. What do you expect this to be? It's in descending order, no greatest common factor, no negative leading coefficient. So you would say x minus 2 squared, right? Because x squared is x squared and negative 2 squared will be 4.
How do you know if it's a special product?
Because the first term and the last term are perfect squares. I have to try.
Okay.
This is the next step in the sequence. Here it is, right? So I go through all these steps. It's a very good question, actually, because I didn't mention that. Do not skip any step from the strategy that I gave you. If you know a different method that you're comfortable with, forget about mine. But if you don't know any method, please do not skip any of the steps. This must be the first, this must be the second question, this must be the third. You can do these together, and this must be the last one for binomials. Again, for trinomials, do not skip any of the steps. I have to try the special product. If the special product doesn't work, then I will fit the polynomial in this category or this category. It's a very good question. Thank you. Okay, so then I'm at the stage in which I'm asking myself, is this a special product? And I'll say, yes, I see the first term is a perfect square, the last term is a perfect square, and this is a minus here. So I expect this to be. But what is the middle term of this expansion that we discussed last Wednesday? 2 times the first times the second. 2 from the formula. So this is negative 4x. Now I'm looking, is this negative 4x?
No.
So then the left-hand side cannot equal the right-hand side. The point I'm making with the second example is this. You cannot just look at the first term and the last term and say, oh, I know it's a special product, without checking the middle term. Because the middle term may not work. Okay, next problem. I know I only have 2 minutes. I'll stop in 2 minutes.
Yeah, so the answer is negative 4x, correct? No.
When I expand this, I get x squared minus 4x plus 4. No, the answer is this. I have to check the middle term, and it happens to be the same. Yes,
That's the answer. Okay.
correct. Yes.
So once you expand them, if they have the same middle term, then it's a perfect square.
Okay, one last one for today. What is it? I cannot skip any of the steps. Please don't.
Yes.
So, is this a trinomial?
Yes.
Good. Is it in descending order?
No.
Very good. Awesome. Y squared minus 22y plus 121. Negative leading coefficient. Greatest common factor. Special product.
isn't it 11 times 11, right?
So what will I write?
1 minus 11.
However, this is not done. I hope that this is the correct answer, but I have to check the middle term. What will, if I expand this using the special products from last Wednesday, what will be the middle term? 2 times the first times the second. What will be the middle term? Negative 22y. Now I check. Is this negative 22y?
Yeah.
So this must be the correct factor form.